yesterday you know that we had started with the equilibria. Equilibria we have done with the for equilibria we have done with the ionic product of water, which is Kw. और Kw का हमने फॉर्मूला निकाला था. I told you yesterday. Kw that is equal to H positive concentration into OH minus concentration is equal to 1 into 10 raised power minus 14. So this is the first formula you should know. And the second formula I told you, that is the pH. So pH that is equal to negative log of hydrogen ion concentration. So these two are the formulas. Okay. By using these two formulas, my dear, you can calculate the pH of any solution. Okay. So yesterday we have done these two formulas. Okay, I have given you the 4 questions yesterday. Okay, so we are going to discuss those questions one by one. Okay, so let's start. Anyone could tell me what was the first question I have given you? Tell me.
What is the pH of 0.015?
Just a minute. What
is the pH?
Is the pH
of 0.015?
Of 0.015
mole per dm cube of
of
H2SO4.
H2SO4. Okay, this was the first question, my dear. Okay, so now we have to find out the pH of this sulfuric acid. Okay, whenever with anything mole per dm cube, these words are written. Okay, so it means this thing will show you the concentration. Okay, so this one shows you the concentration. So this is the concentration of sulfuric acid. So here you should write H2SO4. So if you put the brackets around anything, these are the brackets. So sulfuric acid concentration, that is 0.015. So 0.015 mole per dm cube. So this is the concentration. Okay. Now he wants you to find out the pH. So pH you have to calculate. So you have to calculate the pH. Okay. So what is the formula of the pH? The formula of the pH is negative log of hydrogen ion concentration. But we got the concentration of sulfuric acid up here. Okay. Now keep remember, if you got the strong acid, I told you yesterday, there are the 3 strong acids in the nature: HCl, HNO3 and H2SO4. These 3 are the strong acids only. Okay, so if you are being given any strong acid and you want to find out the hydrogen ion concentration, so the method is very simple. So what should you do? If you want to find out the hydrogen ion concentration, so you have to look in that acid how much hydrogen are present. Yes, Talat Bhatt, how much hydrogen are present in that acid? Talat Bhatt, 2. So we got the 2 hydrogen up here. So you take 2 and multiply it with the acid concentration 0.015 mole per dm cube. Okay, so if you got an acid which got only one hydrogen, okay, so you should multiply the 1 with the acid concentration. Here we got the 2 hydrogen, so we should multiply the 2 with the acid concentration. So it would become 0.03 mole per dm cube. So this is the concentration of hydrogen ion. This only happens when you got the strong acid or strong base. Only. If you got the weak acid and weak base, the method is entirely different. We will discuss it after this one. Because we are only doing right now the pH of strong acids and strong bases. Okay, so if you got the strong acid, okay, and the concentration of acid is given, so you have to look how much hydrogen does it have. It has 2 hydrogens, so multiply this 2 with the acid concentration. So this is the hydrogen ion concentration. Now what should you do? You should use the pH formula. So the formula of the pH, that is equal to negative log of hydrogen ion concentration. Okay, so this one negative log hydrogen ion concentration, that is 0.03. So if you put the value of the concentration, you should use the small bracket, not the, because these square bracket, they show you the concentration. Okay, the concentration is given up here, use the small brackets, put the value 0.03. Now calculate negative log of 0.03. So what you will get? Tell me about it.
1.52.
1.52. So 1.52, that is the pH of acid. Okay, I'm going to repeat it for you. First of all, H2SO4 concentration is given in the question. So if it is a strong acid, you should have a look how much hydrogen does it have. It has 2 hydrogen. So you should multiply this 2 with the acid concentration. So that would give you the hydrogen ion concentration. And now put the value in the pH formula. pH is equal to negative log of hydrogen ion concentration. So hydrogen ion concentration is 0.03. So if you take the negative log 0.03, so this is the answer. This is the pH of acid. Okay, so this was the first question I have given you yesterday. Now question number 2. Anyone could repeat the question for me, please?
What is the concentration of H2SO4?
What is the concentration of H2SO4
Having pH 1.12.
having pH 1.12? Okay, everybody just focus up here. This question is very interesting, so you have to look up here. Now this time, my dear students, he has given you the pH. pH is 1.12. And he wants you to find out the concentration of sulfuric acid. So sulfuric acid concentration, you want to find it out. Okay? So this time, what you are supposed to do, the pH is given. Okay? So use the formula, this one. So pH, that is equal to negative log of hydrogen ion concentration. So put the value up there. The value of the pH is 1.12. Is equal to negative log of hydrogen ion concentration. Okay, so now this is negative up here. If you want to remove this negative, so you should multiply this up here with negative and up here negative. So it will become negative 1.12, that is equal to this negative and this negative. I'm going to write the negative up here. Negative and this is equal. So negative and negative, that would become positive. So it would become log hydrogen ion concentration. Okay. So now if you want to remove the log, okay. So what is the method of it? If you want to remove the log, so you should make the value on left hand side as 10 power. Okay. This is called as the anti-log. In mathematics, this is called as the anti-log. So if you want to remove this log, okay, so make this thing as a power of 10. So 10 power minus 1.12, so that is equal to hydrogen ion concentration. So just calculate it and tell me what you got. 0.075 mole per dm cube. So this is, my dear, the concentration of hydrogen ion. But still, this is not your answer. Why? Because sulfuric acid concentration you want to find out. You know that one sulfuric acid H2SO4 and H positive. So one sulfuric acid, 1 mole of sulfuric acid produces 2 hydrogen ions. And we got how much hydrogen ions? 0.075. So this one would be X. So cross multiply it, what you will get? 0.0375. So it means the sulfuric acid concentration, that would be half. So this one 0.0375 mole per dm cube. So that is your answer. This is the concentration. This is your answer. Did you get it?
Yes, sir.
Okay. Now what I am going to do, I am going to change the values for these two questions, and you people are supposed to do them because practice will make you perfect. Okay. Shall I change the values? Okay. So this one would be 0.027, and this one, that is 0.8. So just do it, my dear. I've changed the values.
1.37.
1.27. Everyone has got the same answer, 1.27? That's perfect. Fatma beta, tell me the answer of the question number 2 if you have done it. How much?
6.3.
6.3. No, beta. The concentration could be less than 1. You just have to change 1 point, the pH is 0.8. So at place of this one, you should write 0.8 only. Only change the other things, beta. Yeah, your answer is 0.079. You send me the message. 0.079. Fatma beta, you should see the recording yesterday. I think you were absent yesterday. That is why you are a little bit confused, whatever I think. And Maria, you are not taking part in the class discussion. You should tell me the answer at the same spot. What the answer you got?
For the second question, my answer was wrong. Or just say it wrong.
Okay.
Sir, 0.079.
Okay, that's fine. Fatma, did you get the mistake where you?
Sir, how do we, if in this case log will be positive?
Beta, the pH is 0.8. So at the place of this one, you should put 0.8. So 0.8. So this is minus 0.8. So here it would be minus 0.8. So minus 0.8. So take 10 raised power minus 0.8. What you got? Come on.
0.15.
0.4.
0.1584.
158. Okay, that's fine. Okay, so this is hydrogen ion concentration. Now put this value up here, 0.158. So divide this value with 2. What you get?
0.079.
Did you get it now?
Yes, sir.
Okay, my dear. Now what is the question number 3? Can you repeat it for me? What is the pH of
0.023 mole per dm cube
0.023 mole per dm cube
of barium hydroxide.
of barium hydroxide, BaOH twice. Okay. Now everybody please listen it very carefully. If you look up here, the concentration of barium hydroxide is given. So BaOH twice. Okay, its concentration that is 0.023 mole per dm cube. So you want to find out its pH. Okay. So now, my dear students, if you look at this thing, so this is actually the alkali because it has got the OH in it. So it produces the OH minus ions. Okay. So if you look up here, if you want to find out the concentration of OH minus ions, so how much OH it got? 2. Okay. Because this is a strong base. I told you in the yesterday's topic that 3 acids are strong, HCl, HNO3 and H2SO4, and bases potassium hydroxide, KOH, NaOH, calcium hydroxide, strontium hydroxide, barium hydroxide and barium hydroxide. These are the strong bases. So this is a strong base. So how much hydroxide it produced? It produced 2. So 2 multiplied with its concentration 0.023. So that would become 0.046 mole per dm cube. Did you get it? So the concentration of OH minus is this one. Okay, but for pH we need the hydrogen ion concentration. So what should we do? We use this formula, Kw formula. So the formula of Kw I am going to write up here, Kw, that is equal to hydrogen ion concentration into hydroxide ion concentration. The value of Kw is written up there. 1 into 10 raised power minus 14. This is a constant thing I told you yesterday. Okay. So this is the value of Kw. The hydrogen ion concentration we have to find out. OH minus ion concentration is this one, 0.046. So this one is multiplied on that side, so it would come on the other side to be divided. So 1 into 10 raised power minus 14 divided by 0.046, that is equal to hydrogen ion concentration. So just divide it. What should be that?
0.17 10 to minus 13. 0.17
17
10 is power minus 13.
minus 13. So that is the hydrogen ion concentration. Okay. Now you got the hydrogen ion concentration. Find out the pH. pH is equal to negative log of hydrogen ion concentration. So negative log of hydrogen ion concentration is 2.17 times 10 raised power minus 13. So if you take the negative log, 12.66. So this is the pH of barium hydroxide if we got this concentration. Everyone got it, beta? Online students, did you get it?
Yes.
Yes, sir.
Of barium hydroxide
Having pH
having pH
13.4.
of 13.4. Okay, guys, now what you are going to do? So barium hydroxide concentration, this time you have to find out the value of the pH that is given, that is 13.4. Okay. Now you should put this value in the pH formula. So this is the pH formula. So pH is equal to negative log of hydrogen ion concentration. So pH is 13.4 is equal to negative log of hydrogen ion concentration. So if you want to remove this negative, multiply this one with negative and multiply this one with negative. So it would become negative 13.4 minus minus is positive. So log hydrogen ion concentration. So if you want to remove this log, you should make this thing at the power of 10. So 10 power minus 13.4, that is equal to hydrogen ion concentration. So just do it.
3.9 into 10 to minus
3.98 times 10 raised power minus 14. So this is the hydrogen ion concentration. Is it clear, my dear? Now, using this formula, you can calculate the OH minus ion concentration. So use this formula Kw, that is equal to H positive concentration into OH negative concentration. The value of the Kw is this one. So put this value 1 into 10 raised power minus 14. Hydrogen ion concentration is given up here. 3.98 times 10 raised power minus 14, and OH negative you have to find out. Okay, so this one will be divided on that side. So 1 into 10 raised power minus 14 divided by 3.98 times 10 raised power minus 14. That is equal to OH minus ion concentration. So what is this? 0.25. So 0.25, that is the concentration mole per dm cube of hydroxide ion concentration. So this is not yet your answer. Why? Because you want to find out the concentration of barium hydroxide. So one barium hydroxide produces 2 hydroxide ions. So you should divide this value with the 2. So have a look up here. Barium hydroxide and hydroxide ion. So one barium hydroxide produces 2 hydroxide ions. And how much hydroxide you got? 0.25. So this one would be X. So cross multiply it, so it would become 0.0125. Okay. So barium hydroxide concentration, that is 0.0125 mole per dm cube. So this is your answer. इन दोनों की वैल्यूज में चेंज कर रहा हूं. इसकी वैल्यू लिखे 0.048 और इसकी लिखें 12.75. चलिए शुरू हो जाइए जरा. 13 यानी 12.98 आ रहा है.
98 है sir.
Yeah, it's 98. 12.98. Okay, dear. So today we are going to start with the pH of weak acids and weak bases. Okay. So I think every one of you know the definitions of the weak acid. Weak acid, an acid which partially ionizes in its aqueous solution. Okay. So weak acid definition, weak acid, an acid which partially ionizes in its aqueous solution. Okay, so that is called as the weak acid. So if you want to represent any weak, I told you the three acids are strong only: sulfuric acid, hydrochloric acid, and nitric acid. Okay, except for these three acids, all the other acids are weak. All, like phosphoric acid, ethanoic acid, citric acid, whatever the name of the acid is given, that would be a weak acid. Okay. So I'm going to take a supposed acid up here like Ha. A word shows for acid, H for hydrogen ion, that it produces the hydrogen ion. So if you take this Ha and you put it into the water, so what would happen? You know that the definition of the acid, acid is a proton donor. Acid, that is actually the proton H positive donor. So anything which donate proton, donate H positive, so that would be the acid. Okay. So now what would happen? This is an acid, so it gives it H positive up here. Okay. So it would become A negative, and this one gains proton, so it would become H3O positive. Okay. And this reversible sign shows that it's a weak acid. If you got the strong acid, let's suppose Ha. If it is a strong acid, so we should write it like that. This one gives this H positive up here, so it would become A negative and H3O positive. So this irreversible sign shows that this one is a strong acid. Okay, if you got the reversible sign, so it means automatically understood that this is the weak acid. Is it clear?
Yes, sir.
Okay, the next thing, you know that I told you in the first lecture, if you got the reversible sign, so the reversible reactions normally reaches at equilibrium. Okay, and at equilibrium you find out the equilibrium constant Kc. So what is the formula of the Kc? I told you yesterday, Kc, that is the product concentration divided by the reactant concentration. So these are the products. So A minus concentration, and then you got H3O positive concentration and divided by Ha concentration and H2O concentration. Is it clear? Now this water concentration is divided on that side, so it would come on the other side to be multiplied. So Kc into water concentration. Okay, so this is A negative. Now please remember, what is this H3O positive? Most of the students, they get confused with it. H3O positive and H positive, they are the same thing. Normally H positive alone does not exist in the nature. It always combined with the water to form H3O positive. So wherever H3O positive is written, it means it's an H positive ion. Okay, because H positive alone doesn't exist in nature. It always combines with water to form H3O positive. Okay, so the H3O positive means H positive. For your understanding, I'm going to write this thing as H positive divided by Ha. I told you this Ha is an acid. So at the place of this one, I'm going to write down the acid. Now, in the first lecture, I told you, if the Kc and water, they are multiplied and nothing is written in the reciprocal, so these two things would multiply to become Kw, which is called as the ionic product of water. We done it yesterday. But if in the reciprocal the acid is present, so Kc and water, they would multiply to become Ka. This Ka, this is called as the acid dissociation constant. And if the base is written up here, base or alkali, so Kc and water, the same thing would multiply to become Kb, which is called as the base dissociation constant. So Ka, that is equal to A negative concentration and H positive concentration divided by acid concentration. Is it clear, my dear?
Yes.
Online students, did you get it up till here?
Yes. Yes.
Okay. Now, if you look this acid, let's suppose this marker, listen, this marker is an acid molecule. So if it's ionized, this is the hydrogen ion and this is the negative ion. So can you tell me if I got one acid and if it ionizes, so this is the H positive, this is the negative. So if Ha ionizes, it produces H positive and A negative. So the concentration of H positive, that is always equal to A negative. So whatever, let's suppose these are the two acids. Okay, so both of them, they produce the hydrogen ion. So you got the two lids, two hydrogen ion and two negative ion. So the concentration of positive and negative ions, that is always equal to each other. Okay, so now what I'm going to do, their concentration, that is equal. So at the place of A minus, I'm going to put H positive because both are having the same concentration. So I'm going to write up here Ka is equal to H positive concentration. At the place of this one, I'm going to write this one because both are having the equal concentration. And then again H positive concentration divided by acid concentration. Okay. Now acid would be multiplied on that side, Ka into acid concentration, that is equal to hydrogen ion concentration square. So if you want to remove the square, put the under root. Square and under root cancel. So it would become hydrogen ion concentration, that is Ka into acid concentration and under root. So my dear students, this is the formula you have to use if you want to find out the hydrogen ion concentration of a weak acid. यानी आप लोगों ने ये नहीं करना, मतलब suppose that we got an acid CH3COOH. अब ये weak acid है, so you are not supposed to count the hydrogen because this is a weak acid. If you want to find out the hydrogen ion concentration, you should use this formula. The Ka value of this acid could be given in the question. The concentration of this acid could be given in the question. So you should multiply these two values, take the under root, then you will get the hydrogen ion concentration. For strong acid, what you did, you just see that how much hydrogen is got and you multiply those amounts with the acid concentration to get the hydrogen ion concentration. But in weak acids, you are not supposed to count the hydrogen. You should use this formula to find out the hydrogen ion concentration, and when you get the hydrogen ion concentration, you should find out the pH by the same formula. pH is equal to negative log of hydrogen ion concentration. And from this formula, you can make another formula. OH minus ion concentration, that is equal to Kb into base concentration and its under root. So this is the second formula. So this is all the calculation to derive these two formulas. So you should learn these two formulas, they are very important. Okay, so tomorrow inshallah we will use these formulas to do the past paper question.